this is the screencast for section 1.5, example 6. We're going to verify that two functions are inverses of each other. Now, that doesn't mean that you take f, find its inverse, and say, okay, done. That was what g was, so now they are inverses. In fact, we have to prove by doing two composition functions, f of g of x and g of f of x, and simplify to make sure that they both simplify down to x for every x in the domain of g. I'll show you my example here. So f of x will be the green function, g of x will be the purple function. So I'm going to first create the composition f of g of x. So instead of x cubed plus 1, I'm going to use the cube root of x minus 1 cubed. Now because I have a cube root cubed, all of x minus 1, they will cancel. So I just have x minus 1 and then plus 1 left over. So then this will equal x. So far so good. Now I need to do the reverse composition. G of f of x. So the g function is the cube root of x minus 1. But instead of using x as the input, I'm going to use the whole f function. So now those parentheses inside the cube root aren't really doing anything for order of operations, so I don't really need them. So x cubed plus 1 minus 1 is just x cubed inside that cube root. Now I'm taking the cube root of x cubed, which does simplify down to x. So now I have systematically shown that f of g of x and g of f of x both simplify down to just x. When you're doing these verifications, please show every single step. I need to know that you have gone through this process and done all of the algebra correctly. I understand that you know it should simplify down to x, but you have to show me every single step. The now try problem for example 6 is number 27. It wants us to confirm that f and g are inverses by showing the two compositions both simplify down to x. So the first composition I will do is f of g of x. So 3, and I'm not going to use x, I'm going to use x plus 2 over 3, and then minus 2 from the f function. Now 3 times x plus 2 divided by 3 simplifies to be x plus 2. X plus 2 minus 2 is just x. So the first composition does simplify down to be just x. So far so good. Now let's try g of f of x. The g function wants the input plus 2 in the numerator divided by 3, and that input is going to be the f function, 3x minus 2. Well, again, those parentheses are not really doing anything for order of operations, so I can just take 3x minus 2 plus 2 and simplify, so the numerator will have 3x left in it, and then still a 3 in the denominator. Now those 3's will simplify or cancel, and I get a simplification of just x.